Hi everyone, welcome to Learning Math with VK. Today we explore lesson 25 in algebra, composition of functions and inverses. Number 1, composition of functions. We can create new functions using addition, subtraction, multiplication, division. And we can also use the composition of functions. This is what a composition of function is. F circle G or F composed G is defined as F of G. So composition is just substitution. Okay, example. Let fx equal 2x plus 1. Gx equal 5. Hx is 3x squared minus 1. We can do F composed G. This is F of G. Do the substitution. G is 5. So F of 5. Same thing, do another substitution. 2 times 5 plus 1. 11. F circle H or F compose H. So it's F of H. And that is F of H is 3x squared minus 1. Do the substitution into the F function. 2 times 3x squared minus 1 plus 1. And we have 6x squared minus 2 plus 1, which is 6x squared minus 1. We can also compose F with itself. F circle F, just F of F. And F of the function F is 2x plus 1. Similarly, we do the substitution. We sub 2x plus 1 into x. So we have 2 times 2x plus 1 plus 1. 4x plus 2 plus 1. 4x plus 3. Pretty cool, huh? Let's move on to inverses. Let's say we have a function that map a set of input to output. So input, output. X, the function is f, we map it into fx. The inverse, if exists, would go the other way. F inverse, if exists, okay. Notice that from this mapping here, the domain of f is the range of f inverse. So the inverse function switches input and output. Inverse switch input X and output Y, because we can write fx as y. Okay, so now let's take a look to see when we can have an inverse. We have two types of function. We have a one-to-one function. Input, output. Okay, so for a one-to-one function, one input go to exactly one output. So when we go the other way, then yes, there is an inverse. F inverse is one-to-one. Onto function. Similarly, input, output. One input go to this output. Another input can go to the same output. That is F here. However, when we look at F inverse, so this go here and it go here, and this go here. Notice that F inverse is not a function. There is no function F inverse. There is no F inverse. Because one input cannot have two distinct outputs. Properties of inverse functions. These properties are very useful to study logarithmic function so that we can do problem in finance, biology, chemistry. And they are also useful in the study of inverse trigonometry. So we can do problem in physics and engineering. Let's take a look at an example. Fx is 2x plus 4. This is the straight line, so it's just a one-to-one function. Of course, they're going to have an inverse. And we can figure out the inverse by rewrite fx as y equal 2x plus 4. And then remember the inverse switch x and y. So we can switch x and y. And solve for y. Okay. X equal 2 y plus 4 minus 4 minus 4. X minus 4 is 2y. And then multiply both sides by a half. We have y is distribute. Half of x minus half of 4 is 2. The answer here is F inverse. So what are the properties here? The first property is if we do F circle F inverse, right? Let's see what we have. Now there is F of F inverse. So it would be F of 1/2 x minus 2. Substitution. 2 times 1/2 x minus 2 plus 4. Distribute, so I have x minus 4 plus 4. X, F circle F inverse is x. Do the same thing for F inverse circle F. So this F inverse of F, and that is F inverse of 2x plus 4. F inverse is 1/2 sub x for 2x plus 4 minus 2. Distribute, we get x plus 2 minus 2, and we have x. So F inverse of F is x. It's the first property. When we do the composition of F and F inverse, or F inverse and F, we have x. The second property comes from the graph of these two. So let's graph them. X, y. Fx is 2x plus 4. 1, 2, 3, 4. First point is the y-intercept. Slope is 2, so we go up by 2, 1, 2. And over 1. Get a point right here. Get a straight line between the 2 points. Okay, so there's the Fx. F inverse x, that's y-intercept -2, -1, -2. Slope is 1/2. So go up 1, to the right by 2. Let's take a look. Okay. This F inverse x. And notice that we can draw the line y equals x. You will see that F and F inverse, their graphs reflect over the line y equals x. Take a look at another example. Here come example. Say we have a fx equal to x to the 3. This is a one-to-one function because the one input, only one output. We can figure out the inverse function. Y equal x to the 3, and then switch x and y. And solve for y. X equal y to the 3. Now to solve for y, we got to get rid of the exponent. To get rid of the exponent, we can take both sides to the power 1/3. And we see that y is x to the 1/3. This f inverse. Let's graph each one using Desmos. Desmos is amazing. So we have the first function is x to the 3. The second function is x to the power 1/3. And they are inverses of each other. Okay. Now take the ruler, sketch the line y equals x. And then you see that, oh my God, this line y equals x right here. The red function is the f of x. The blue function is f inverse of x. They reflect over the line y equals x. Pretty cool, huh? Thank you for watching. I hope you found the content useful. Please like and subscribe to help the channel grow. I'll see you in the next video.